two circles are said to be orthogonal if the angle between the circles is equal to 90 degrees. So it's a special case. If two circles are such that the angle between circles is equal to 90 degrees, then we say that the circles are orthogonal. So in this case, what happens is theta will become 90 degrees. So obviously alpha will also become 90 degrees because theta and alpha are supplementary angles. So we have already seen that theta plus alpha is equal to 180 degrees. So if theta is 90, alpha is equal to 90. So the lines AP will coincide with AC1. The line AS will coincide with AC2 for orthogonal circles. Now what is the condition for orthogonality? We have seen that cos theta is equal to d square minus r1 square minus r2 square by 2 r1 r2. Cos theta is equal to d square minus r1 square minus r2 square by 2 r1 r2. So if theta is equal to 90 degrees, obviously cos theta is equal to 0. So 0 is equal to d square minus r1 square minus r2 square by 2 r1 r2. Hence the condition will be d square is equal to r1 square plus r2 square. So if this condition is valid, if the distance between the center square is equal to r1 square plus r2 square, then the circles are orthogonal to each other. So this is one condition, this is the first condition. So let us derive a more useful condition than this. The second condition is regarding the coefficients of x, y in the equation of the circles. So let us say that x square plus y square plus 2g1x 2f1y plus c1 is equal to 0, x square plus y square plus 2g2x plus 2f2y plus c2 is equal to 0. So let us say that these two are the circles. So when will these two circles be orthogonal to each other? So let us derive the condition here using this. The center is minus g1 f1. The second center is minus g2 comma minus f2. r1 square is g1 square plus f1 square minus c. r2 square is equal to g2 square plus f2 square minus c2. So what does this condition give you here? So the distance between the centers whole square, g1 minus g2 whole square plus f1 minus f2 whole square is equal to g1 square plus f1 square minus c1 plus g2 square plus f2 square minus c2. So if you expand these squares, g1 square, g1 square, g2 square, g2 square will get cancelled. f1 square, f1 square, f2 square, f2 square will get cancelled. So what will be left is 2g1, g2 plus 2f1, f2 is equal to c1 plus c2. So 2g1, g2 plus 2f1, f2 is equal to c1 plus c2. So this will be the equation or the condition which will be satisfied if two circles of this form are orthogonal to each other. So you need to remember these two conditions. First is d square is equal to r1 square plus r2 square. The second condition is 2g1 g2 plus 2f1 f2 is equal to c1 plus c2. So let us take a very small example for this.